Hello ICSE warriors, welcome back to my channel. My name is PrachiSharma. I am so happy with the overwhelming response I'm getting on the channel. So we have finally decided to go ahead and release a series of sample papers similar to the ones that is going on right now. So we have a test series going on right now, and similarly we have decided to put forward a sample paper series for chemistry just for you all. Now, I have noticed that a lot of you are taking help from the videos and understanding from the videos, but have not yet subscribed. So, I would request you to subscribe so that once I upload a new video and something interesting is going on the channel, you get a notification and you are up to date with what is happening and what are important questions, what important content is coming up for class 10th grade ICSE chemistry. So go ahead and subscribe the channel. Now, today is the day that we are working on the test paper of nitric acid. The test paper again was released on the Telegram channel yesterday. Today we are working on the solutions of that test paper. If you did not get a chance to subscribe to the Telegram channel, go ahead and look in the description box for those details. On the Telegram channel, you can personally text me and discuss if you have any particular doubts and how you can target for your board examinations. Now, without wasting any more time, let's get started with nitric acid. Alright students, let's get started with the test paper. So the first question is fill in the blanks. Now a lot of questions in the fill in the blanks are based upon the exceptions about nitric acid. So let's look into it. For example, the first question, dash and dash react with, so V means very dilute HNO3 to liberate hydrogen. So one important thing about nitric acid you have to remember is that nitric acid does not give hydrogen when it reacts with metals except manganese and magnesium when HNO3 is very dilute. Okay, now what is the reason for this? This is an important reasoning question. Why does HNO3 does not give out hydrogen with other metals? So the reason is that it's a very good oxidizing agent. So instead of giving hydrogen, you end up getting oxides of nitrogen. So that is what happens, and you do not get hydrogen gas in the output. So the answer for this particular question is pretty simple. Manganese and magnesium react with very dilute HNO3 to liberate hydrogen. So manganese and magnesium. Now next question is nitric acid is a strong dash, therefore it does not liberate hydrogen on reactions with metals. So nitric acid is a good oxidizing agent. So let's just write that it is strong oxidizing agent, therefore it does not give hydrogen. Moving on to the third question. Nitric acid is manufactured by dash process and the catalyst employed is dash. So nitric acid is manufactured by Oswald process and the catalyst uses platinum. So let's write that Oswald's process and the catalyst is platinum. Moving on to the fourth. Copper on reaction with concentrated nitric acid produces dash, dash and dash. Now this is also one important thing to remember, that copper on reaction with concentrated nitric acid will give you nitrogen dioxide, and on reaction with dilute nitric acid you end up getting nitric oxide, that is NO. Okay, so let's write that. The next question is based upon dilute nitric acid. So I'm going to write both of the answers for you. So the first one is copper on reaction with concentrated nitric acid will give you copper nitrate, water and nitrogen dioxide. And for the next one, copper on reaction with dilute nitric acid produces copper nitrate, water and nitric oxide. Okay, I hope that much is clear. Let's move on to the next question. So the next question is copy, complete and balance the following equation. So the first is copper with HNO3. So if they have not mentioned whether it's dilute or concentrated, you are gonna assume it's concentrated. So let's start with the answer for that. So that would be copper nitrate, so CuNO3 whole twice plus water plus NO2. Then C with HNO3. So C will give you carbon dioxide plus water plus NO2. Then sulfur plus HNO3 will give you sulfur dioxide. So H2SO4 plus NO2 plus water. Then P will give you H3PO4 plus NO2 plus water. Okay. Now moving on to the fifth one is NaOH plus HNO3 will give you NaNO3 plus water. I hope this much makes sense to you. Now, the important ones that you have to remember from this is that what does HNO3 gives you with sulfur, or which acid does it produce? So you should know it is H2SO4. So such kind of questions can come from this particular information also. Now, let's move on to the next question. Question number 3 is simple, straight, true and false. Nitric acid is a diabasic acid. So diabasic acids are those which have two displaceable hydrogen atoms. So in this case, that's not true. It's not diabasic, so it's false. Okay, it's monobasic. Monobasic means one hydrogen atom is displaceable. HNO3, you can replace one hydrogen atom. Now, moving on, nitric acid is a strong oxidizing agent. That is true. We just discussed that in question number 1. Nitric acid is manufactured by Ostwald process. That is also true. We have also discussed that. In oxidation chamber, high temperature is maintained. Now, this is false. Now, what is the reason for this? So, the reason is that at high temperature, so when you are manufacturing nitric acid, and you keep high temperature, so nitric acid has a tendency to decompose itself at a high temperature, and we don't want that. We are trying to manufacture HNO3. Why would we want it to get decomposed? Okay, so we won't maintain high temperature. The second reason is that the reactants you are using, so the outcome product will become sodium sulfate. So sodium sulfate has a tendency to get stuck at the inner lining of the glass apparatus, and it is a very sticky substance, so it will be very hard to get it out from the apparatus, and even while doing so we are gonna damage the apparatus real bad. So that is the reason we do not maintain a higher temperature when we are manufacturing nitric acid. Nitric acid on heating gives nitrogen dioxide, water and oxygen. Yes, that is true. Now, choose the correct answer. Nitric acid is manufactured by Ostwald process. The second is sulfur on reacting with concentrated nitric acid produces sulfuric acid. I just told you this question in the first part itself. Copper on reaction with dilute nitric acid produces the following oxide of nitrogen. So you have to remember they are talking about dilute. So for dilute, you will end up getting nitric oxide. Alright students, let's move to the fourth part of this question. So that question says that the gaseous reactants used during Ostwald's process are, so that is ammonia and oxygen. If you see option D, so that's ammonia and oxygen. The fifth question is, commercial sample of nitric acid is pale yellow in color due to the presence of dissolved nitrogen dioxide. And you can just mark D in this one. Now, if you move on to question number 5. So question number 5, what do you observe when? So the question is wrong. They are not asking about the observations in this. So this is based upon the preparation of nitric acid, and the questions are based upon that. So you can simply write the question as answer the following. Answer the following. Name the reactants used for the preparation of nitric acid in the laboratory. So when we prepare it in the laboratory, so either you can use sodium nitrate, or you can use potassium nitrate. So any of those will be able to give you the products. So let me write that here. So sodium nitrate or potassium nitrate with concentrated sulfuric acid. Moving on to the next question, write balanced chemical equation for the reaction taking place above. So I'm gonna just write it here. So that's question 5, A part, sorry, B part. Let me just write that. Question 5B part. So that is KNO3 potassium nitrate plus H2SO4 that is concentrated at a temperature lower than 200 degrees Celsius. You end up getting KHSO4 plus HNO3. Okay, so I hope that makes sense. Now let me just scroll it down so you can see it now. Now it's important to mention the temperature because it's a lab preparation and the temperatures are important. Any of the questions that I don't find enough space to write it on the screen, I will write it towards the end of the test paper, and you can find the solution page in the description box. If you still have any doubts or concerns, you can definitely text me on Telegram channel, or you can leave a message in the comments box and I will get back to you. Let's move on to part C. Why the apparatus used for the preparation of nitric acid made of glass? So the answer is that nitric acid vapors that are produced are highly corrosive in nature, and if the apparatus is not of glass and we use rubber or cork instead, it has a tendency to damage those materials. Therefore, any lab preparation for nitric acid, the entire apparatus has to be made of glass. Let's move on to D. For the lab preparation of nitric acid, why the reaction mixture should not be heated beyond 200 degrees Celsius, give two reasons. So the first reason is similar to what we did in HCl. So that was that if you go beyond 200 degrees Celsius, a sticky substance, sodium sulfate, is produced, which would end up sticking to the apparatus, and it's very hard to get it out of the apparatus, and the entire apparatus gets destroyed or spoiled. So that is one reason. The second reason is that since we are producing nitric acid and the temperature starts to exceed, so nitric acid, instead of getting produced or getting stored in the apparatus, it would start decomposing itself due to the high temperature. So we do not want a decomposed nitric acid compound. We want nitric acid as a combined compound. So we will maintain the temperature at below 200 degrees Celsius. Since I don't have enough space, I'm gonna just discuss these answers and write the answers at the end. Let's move on. What do you observe when A part is concentrated nitric acid comes in contact with skin? When concentrated nitric acid comes in contact with our skin, it turns yellow in color. So I'm gonna mention that skin turns yellow. So let me write that. Skin turns yellow. Now nitric oxide comes in contact with atmosphere, so reddish brown gas is evolved. So reddish brown gas. Next question is, the following questions are related with the lab preparation of nitric acid. First, what is the special feature of the apparatus used in the preparation of nitric acid in lab? So we just discussed the apparatus should be made of entirely of glass, and the reason is that the vapors of nitric acid are highly corrosive and can damage any other material like rubber or cork. So let's move on to B. During the lab preparation of nitric acid, why the reaction mixture is not heated beyond 200 degrees Celsius, we just discussed it. First, sodium sulfate, very sticky apparatus, gets damaged. And the second one is that nitric acid has a tendency to decompose at a higher temperature. Let's move on. Name the metallic nitrate that dissipates on heating. So that is lead nitrate. So that is one of the naming that is given in the chapter itself. So lead nitrate. Next is a colorless gas which becomes reddish brown when it comes in contact with atmosphere. So if you can take the information from right here, so that is your nitric oxide. Moving on, write the equation for the reaction of dilute nitric acid with copper. Okay, so you have copper plus HNO3 will give you CuNO3 whole twice plus water plus NO. Why NO? Because they have clearly mentioned dilute nitric acid. If it was concentrated, you would get nitrogen dioxide and everything else stays the same. If it is dilute, you get NO and everything else stays the same. Let's move on to the next one. Explain the following. Dilute nitric acid is generally considered a typical acid, but not so in its reactions with metals. Why? What's the reason for that? So, the reason is that nitric acid is extremely oxidizing in nature. It's a very good oxidizing agent. So, instead of giving out hydrogen gas, it ends up giving us oxides of nitrogen. Okay, we discussed that when we were working on the first question of this test paper. So it's a good oxidizing agent, therefore instead of giving hydrogen as the output product, it ends up giving us oxides of nitrogen. Make sure, students, all the questions that I'm discussing and I'm giving you the verbal answers, either you take note of the verbal answers or make sure that at the end of the session you are able to download it from the description box and you can get the answers from there. Now moving on, concentrated nitric acid appears yellow when it is left standing in a glass bottle. So when it is left standing in the glass bottle, we just understood that you get, where did it go? Which was that question? Yeah. So you end up getting a yellowish, it's yellow in color because nitrogen dioxide gets dissolved in it. So let me see. For example, this one, the fifth one. So if you can see the fifth one, it's directly there. It is due to the presence of dissolved nitrogen dioxide, which gives it a yellow color. Then an all glass apparatus is used in the lab preparation of nitric acid. Again, it is the same question being repeated. So I hope by now, since these are important board questions, so I hope by now you are able to understand that lab preparation of nitric acid is highly important. Then why the apparatus is all of glass, it's important. Then the nitric acid's reaction with copper's reaction with dilute nitric acid is important, and concentrated nitric acid is important. Both of them are important. Then color of nitric acid, why is it yellow? That is also important. So you have to remember and see that these questions are being repeated often. So that means these questions should be memorized well and you should understand the concept well. So let's move on to the next question. The next question is all glass apparatus. So we understood that one as well. The 11th question says that name the following. The chemical name of an unstable brown colored compound formed during the brown ring test is nitrosoferrous sulfate. I'm gonna write it somewhere here. Nitrosoferrous sulfate. Okay, so this is the unstable brown colored compound that gives you the brown ring in the brown ring test. Now moving on, two metals which react with dilute nitric acid to liberate hydrogen. This was the first question of the test paper. So the two metals which do give hydrogen with nitric acid are manganese and magnesium. Manganese and magnesium. Now let's move on to the next question. See, gas liberated when potassium iodide reacts with concentrated nitric acid is iodine. So iodine. Now D, a yellow non-metal formed when nitrogen sulfide gas is passed through concentrated nitric acid. A yellow compound, always try and think about it. It can be somewhere around sulfur. And if you have hydrogen sulfide there, that means you would have sulfur. So the answer will be sulfur. Now the next question is 12. Multiple choice question. Choose the correct answer. Name a solution which absorbs nitric oxide. So the solution should be ferrous. Okay, so ferrous sulfate solution has a tendency to absorb nitric acid. So ferrous sulfate solution. Second is a metal nitrate, which on heating with nitric acid is changed into metal. A metal nitrate which turns into a metal should be silver nitrate. Okay, so silver nitrate has a tendency to convert into metal on reaction with nitric acid. Now, moving on. Gas evolved when sodium hydrogen carbonate is added to nitric acid. So, of course, when you have sodium hydrogen carbonate, you have a carbonate. That means you have a high tendency of carbon dioxide coming out unless there is an exception given to you. So, the answer would be carbon dioxide. Now, the fourth part is brown fumes of gas evolved when concentrated nitric acid is heated with copper turnings. So, brown fumes. So whenever you have reddish brown fumes given to you, the answer is always nitrogen dioxide. So nitrogen dioxide. Fifth, nitric oxide is used in the manufacturing of explosives. Now this is not in the syllabus, but if you would like to understand the answer for this, the answer is C. So this is known as trientrotoluene. Okay, so I hope all this is end of the test paper. I will make sure that all the theoretical questions that I verbally discussed, I will mention the answers right here in this portion, and you can download this answer script from the description box. So students, the last answer is known as trinitrotoluene. I always have a tendency to mess up the pronunciation, so please excuse me for that. So, this is it for today's session. I hope it was a fun session for you and you were able to go through all the questions and understand the correct answers for them. So, the bottom line is that for nitric acid, the important parts are what is Oswald process, how are you creating a nitric acid in lab, what are the precautions you're taking, what kind of apparatus you are using, what is the temperature you're maintaining, how is nitric acid reacting with copper in dilute and concentrated state? So all of these portions are highly important. So I hope you were able to get a hand on it, and please make sure you subscribe this channel and share this video with your friends and family, and make sure that they are able to understand study of compounds and being prepared better for the board examinations. Now, as I already mentioned that you can reach out to me on the Telegram channel, message me personally and discuss your doubts if you have any, or suggest me anything specific you would like me to cover in the next video session. So that is it for today. We'll catch up tomorrow, and tomorrow's video would be sulfuric acid. Thank you. I hope you have a beautiful day.